Welcome back everyone to part 2 of the video to describe the test program generation process for the Agilent i1000 systems. We'll pick up from where we left off in part 1, where we are in the process of doing probe placement. So once the probe placement process is completed, you will get a summary results at the bottom of the GUI. And we got 809 probes that is successfully placed, and there is the breakdown of the different probe types that is being used in the placement itself. Next, you can actually generate a probe placement report where you can get a physical report telling you where are the probes being placed, and if there's any probes that is not being placed because of some constraints issues like the size of the test pads and the force of the probes, stuff like that. You will have all these results in this log file itself. So it's pretty good log file for you to review. Once that is done, click OK, and the probe placement results will be updated to the column again on the right side of the GUI itself. So now you see that the graphics has got some new information being added, and those are basically the newly added probe locations. So again, what I'm going to do now is to use the layer list and turn off some of the layers that we do not want to see, so as to keep the graphics as clean as possible to see our progress on. So I'm going to just turn off some of the layers that I do not need at all, leaving only the two new layers that was being created by our probe placement. Just click apply, and it's a lot cleaner right now. So with the graphics now being cleaned up, leaving only the probe placement details, let us just zoom in into a specific portion of the board just to show you the probe being placed. So you can see there are two sets of probes, one for the top and one for the bottom. Every probe will have a number, and this is precisely the number starting from probe number 1 in running sequence all the way upwards, and this is what we call the nail numbers. And on the right side of the screen, what you have is that the data has already been updated in terms of the number of probes being placed and whichever probes that is still not being placed. Next step, we will want to sort the probe numbers such that it is in a certain flow, so that it actually helps the fixture vendors in wiring the fixtures and also make it easier for the user to debug. So just go ahead and click on the probe name sorting, and you get a GUI that looks like this. We can choose the algorithm for the numbering. We can also choose the starting point on the board, in this case is lower left, and also to enter some prefix and change the increment levels of the probe numbering over here. So I'm going to leave everything standard and just click OK. And it will take some time to run, and what happens is that the software will now go ahead and renumber all the probes again based on whatever that's being set in this GUI. So once that is done, you will see the sequence line being imposed onto the probe numbers, and also the probe numbers has already been redefined. So the red lines is for the top side probes, and the blue lines is actually for the bottom side probe, which is green in color. What we're going to do now is to again clean up the graphics a little bit, such that we will see only the top side probes, just to give everyone a clearer picture of how what is the result of this probe name sorting sequence. So I'm just going to take out some of the layers that is related to the bottom side, and just leaving only the top side probes to be displayed on the GUI itself. And now it's a lot cleaner. Click apply, and you leave with only the top side probes. Let's do a zoom out view of the whole board. and so you can get a whole view of how the GUI, or rather how the sequencing algorithm has assigned the probe sequence. You can see that the red line is now being representing the probe numbering sequence. So now that we completed the top side, let's go and take a look at the bottom side also. So again, on the graphics layer list, I'm just going to turn off the views for the top side probes, and also enable the views for the bottom side probes instead. Okay, only the bottom is now enabled, and you will see now that the graphics is now being updated with only the bottom side view. And you can sort of see that the actions, or rather the path that it takes for the sequencing, whether we selected the algorithm called swipe, and you can see that the sequence path is actually going from left to right in the bottom side view itself. So let's turn on everything now to with the top and bottom view, and we are almost there to get our pins and nails files. Okay, top and bottoms all turn on, and the last thing to do now is to actually export what we have into the pins and nails files. Click the export button, and we can just select the i1000 output module from the CAMCAD software itself. Click on OK, and the i1000 pins and nails files and the ATD files will be generated for you at your target folder. So let's give it some time. Okay, that is done. So now let's minimize the CAMCAD GUI, and let's look at the output files that we got. So we got 3 files: the ATD, which is a test program for the i1000, the nails, and the pins files. So let's open up the ATD and see what do we have inside, how does it look like. So for a fresh ATD, basically it is a bunch of test steps that is being written for the board itself. So this is the format for the i1000 to read. Then you have the nails files. Let's open that up. Opened. Okay, you have a listing of the nail numbers on the extreme left, and also the XY followed by the net name and the pins that it is being connected to. So this is actually standard format from FabMaster. And then you have the pins files. For the pins files, it is basically listed by the device. You have the pin numbers of the device and its corresponding nail number that it is being connected to. So there you have it. With the 3 files, you are ready to run the program on the i1000 and start your debug. So I hope that this video has given everyone a good understanding of how to generate an i1000 test program using CAMCAD. Thank you very much for watching, and have a nice day. Bye bye.